So let's go ahead and let's replace this number here with a slider so that we can make that dynamic. And actually, as I look at that, I think 5 is incorrect because 5 would actually be 6 because it includes 0. So let's make that be 4. And I think that was actually what was going on before. So yeah, this should be 5 would be 4 plus 0. Great. Ooh, and I see I see one more error I just observed right here where this is saying 1, 2, 3, 3, 5. These numbers are correct here, but the numbers that are being displayed in the interface are wrong. So let's fix that. And that should be color 3, fill color 3. So fill color 4. Is that right? Yeah, there we go. Okay, and I think probably, where do I want this? Maybe just above random seed, above blend. Let's put in a blend control. I guess this will only be used when we actually choose blend from our fill type. So I'm just going to go ahead and duplicate the random seed. I'll copy and paste it. Blend number. And our min is gonna, we always want to blend 2, and our max is always gonna be 4. So let's see, is that right? Maybe 1. 1 includes 0 and 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. Great. Let's make the default be 1. So we've got a blend number here that goes from 1 to 4. And then down here in our code, let's just pass that in for this number. And I'm reusing that code twice here and here. And I want to replace actually all this with that function, but then for my index, I'm just going to pass in 0. But then let's go ahead and let's make sure that let's establish that as a variable. And probably, let's see, that doesn't need to be inside the for loop. It doesn't matter too much. Let's just set it up here above position, since let's keep all the fill stuff together. So fill, and then let's say float. Blend num. And what did I call it up here? Color count. Color count is equal to blend number. That could be confusing variable names, but that's okay. Let's replace that then with color count there. Cool. Now one really cool thing is, because that's a float, look at that. That's cool, we can animate that. It's going through all those different colors. If we can add more count, you can see that blend number will kind of scale through my blends, right? That's a pretty cool effect. So I can see over here in my fill type that I've still got the blend 2 and blend 5 option. Now actually I was going to have these when I wanted to have a blend 2, blend 3, blend 4, blend 5 options just in the drop down. But we've changed this with a single blend and then, this blend number. So let's go ahead and let's just reduce that down to one option, which would be blend up here in the JSON. And that's right here, blend 2, blend 5. Let's delete that. And in the values as well. Great. And then in my distribute mode, I would like to also maybe hook that into the blend number, so that also can control the blend. So let's go back down and do that. I'm getting quite a lot of scrolling here. So one thing I like to do is add these kind of all this verbosity in the code with these really descriptive variable names, but it does make for a lot of scrolling. I've got a lot of stuff like this too, which makes it easier to see and read, but it can then kind of make it hard to find things later. So right here, I can see that actually originally we did this as a mistake. I put in, instead of having the index be the controller, I just put in 0. And so all this really is we're doing is we're just returning that. So I definitely don't need the mix. So let's get rid of that. And let's just type in the colors. So fill is just equal to the colors array. And we'll put in step value. And I'm going to return the RGB, just like we've got up there. And I don't need color count anymore either, because that was just a placeholder. And color count is being redeclared, so that's bad. So that color count is actually just coming from this value anyway. So let's try that, and that throws an error. And that's because this needs to be cast as an integer. So we have distribute, and this then, cool, it's going to go ahead and change the colors as it moves through the iterations. Now there's one more error here, and actually I didn't observe it till I recorded this a few times, and I noticed that actually this is starting from 1, you'll recall, and goes to 4. But actually, because this is an array, it starts counting from 0, we're going to have to add 1. So let's just add 1 to color count. Okay, let's test it. And let's see. Yep, that seems to be working. Green, purple, orange, aqua, purple. Okay, great. So that's going to do us as far as I think fill types are concerned. Obviously, there's a lot of different options here, right? A lot of variations. I'm sure there's a lot of things we could do as far as the color assignment is concerned. But I think this is going to go ahead and we're going to close out our ShapeMaker plugin in series as far as that is concerned. I think one more thing I'd like to add is an FFT. And so something that VDMX and I suppose other host environments that could support ISF can supply is a special kind of texture. And that kind of texture will have value in the audio values. And an FFT will actually, besides returning a pixel value for the overall audio amplitude, it can also return a pixel value for the frequency response. That's what the FFT is about. And so we haven't actually dealt with textures yet. We haven't looked how to pass an image or a texture into our shader code. And we haven't looked at how to sample those. So that also, I think, will be helpful for us. So this next bit is really cool. And actually, quite a lot of code and functionality is going to happen, but we really don't have to write it because mostly it's implemented for us already. We can get all this stuff hyper audio reactive with just a few lines of code, thanks to the ISF spec. So what I'm going to go ahead and do is at the very top here, above everything, I'm going to add in one more input. And this input will be a FFT image. Put it like that. So something that we can do is we can actually pass in images into our ISF, into our shader code. And ISF provides a nice interface for doing this. Right up here, you can actually just declare images. Now, I'd say the most common thing is actually just pass in an image either from a live camera or from your media or layers inside VDMX or your host environment. But if I just declare this FFT image and I save, then all of a sudden, look at that, we get an option for this and we get an audio stream. So what this is going to do behind the scenes for us is actually it's going to draw a picture. It's going to draw like a little image based on the audio coming in. And FFT, what it's going to do is it's an algorithm. FFT is an algorithm that samples across a time domain. It samples different frequencies across a time domain. And of course, if you want to know more, you can go to Wikipedia, and there's tons of useful things, animated GIFs, and we'll tell you, more than you ever want to know about FFT. And then additionally, if you want to know more about the specification and the implementation in ISF, then check out the interactive shader format spec. And there's, let's see, about inside the specification version 2.0. This has actually just been added in 2.0, so this is kind of exciting. There's a bunch of specifications for the options and syntax and stuff that audio FFT would expect. Okay, so enough talk. Let's implement it. As I mentioned, this is just going to be a couple lines of code. and we're going to get a lot of bang for our buck. So let's come back here into our main loop. And inside our main loop, while we're setting up all these kind of table setting variables, let's come up here and also we'll generate an FFT. And let's create a vec4. And the vec4 is actually just going to hold some values. And what we want to do is we want to refer to the FFT image. Now the FFT image is actually coming in as an image. Think of it like a QuickTime movie maybe, or some other image format. So what we need to do actually is we need to sample it. And to sample it, we're going to use another ISF function called image normalized pixel. And what this is going to do is you feed it an image and then a coordinate, and it will return a value. And what we're doing is we're returning a vec4. So with our image normalized pixels, we need to then tell it which image that we want to analyze. And then it actually takes a second argument, which is where do you want to sample from? So the sample is going to be a vec2, and that's just a position. So the default for FFT image, I believe, is to send you 256 pixels, like 1 pixel tall by 256 pixels, right? And so what we want to do is just like kind of sample, if you can visualize this, just sample along the pixels horizontally. Yes, along the X. And so we want to sample them all. So we'll do index. So our good friend index, what we do is we kind of sample along from left to right. And then one problem I see here is actually we haven't declared index yet, so we're going to move all this code a little lower after we have an index value. And so that means it's going to have to go inside our main loop, unfortunately. So that might slow things down a little bit, but let's see. Because we want to just sample as long as there's values, 1, 2, 3, 4, etc. We want to sample along that 0 to 1 range. And then that's for the X component. For the Y, we just want it to be 0. Okay, and then what I'm going to do is I'm going to reduce all this vec4. If this is going to return red, green, and blue, so we can throw them away, or we could just like throw away all the values of the red, maybe red channel, or we could just average them all together. So I'm going to say FFT val is equal to, let's just average anything that might be in the red channel, green channel, and blue channel. And the average formula is the sum divided by the count. There we go. So now this FFT val, we should just be able to plug this in just about anywhere and get an audio responsive result according to the frequency. So let's just try it. Where can we put this? Let's put it in, well, I suppose let's put it in position. So this is distributing through the X. Let's just come here to 0 and let's put in FFT val. Let's see what happens. Hello. Hello. Hello there. I'm making a VU meter. Hello. Let's play some music rather than me say hello over and over and over again. Cool. And this is just using the built-in microphone. I can use audio capture. I could route, audio around my system in various ways to have it flow into ISF if I like. And of course, this FFT val, anywhere you see a number, you can put this thing, right? You could do size times FFT val, and that's going to get us, again, a pretty audio responsive result, even though that's giving us a bunch of zeros. So maybe we want 1.0 minus to give us the inverse. And that's kind of interesting. Or maybe we want it to control the rounding. And that means as they round, they become kind of like squares. notice it gets really round. Let's really crank that up so we can see it. Cool, so they go from like squares to circles. So yeah, just about anywhere you see a number, we can multiply it or attenuate it, I guess. Do whatever we want, add it, offset it by an audio, and that is pretty darn cool. So something probably we want to cover right away is how you'd use this in VDMX rather than ISF, since this little guy pops in with a built-in microphone, but it works a little bit differently in that environment. So let me just go and pause this music. I suppose I should call out also my friend who made that music because he's awesome. That's nonagon.net, so a quick plug for him. I've been using his some of his unreleased music here, so you guys should check out his work at Nonagon. So let's see how we might use this inside VDMX. So I'm going to go ahead and we're on ShapeMaker 04. I'm going to save and then fire out VDMX, and we'll launch it. And let's bring it in. There we go. And I've got the same thing here now inside VDMX. That's a little confusing. I'm just going to hide the ISF editor for now. There we go. So we can see what we're doing here inside VDMX. And we don't have that audio. We don't have that. And then you notice here, the FFT image here in the interface, there's nothing here. And what we need to do is come here and create an audio analysis plugin. Now in the past, I've just taken the value. There's been some data that's been published off the audio analysis. Like if I come here back to my layers and I select this and come here and come to my data source, now that's published, right? Like the value of filter 1, 2, 3, the peak frequency and the peak frequency magnitude. But actually, once I create an audio analysis, it also behind the scenes publishes this guy, an FFT, which is basically what the ISF is doing for us. So let me go ahead and grab that. And that's that same thing. That's that same image we were using before, basically. Cool. And you can have yourself all kinds of fun now here inside VDMX and do all the cool things that VDMX can do. You know, assign more of this to more audio stuff. Change the colors. Hook this up to MIDI controllers. Whatever you like. Okay. So hopefully you kind of enjoyed a lot of the things that we've learned in this training series. The last step for me is to go through and show some of the demos that I originally kind of started with when we started this journey, and that is the initial piano demos that I did. So I built some presets for my ShapeMaker plugin, and I'd like to share with you some of those looks, some of those builds, to maybe have you guys as a good jumping off point to make all your own stuff inside VDMX. Now, obviously, the point here is tons of customization. I'm going to let you know that this version that I built up of this plugin, actually, I made a bunch of different decisions, and I'm getting a bunch of different looks than where I started about, maybe 2 or 3 weeks ago when I started recording these videos. And so the idea here is that you can go in and you can make as many different adjustments as you like in the code. You can add in oscillators, you can add in sine waves, you can add in FFT, you can add in 10 colors instead of 5. All this stuff is meant to be customized and to try and get different looks.